All right, guys, welcome to the 1-2 video. Here we're going to talk about order of operations and evaluating expressions. We got two objectives for today. After the lesson, we want to be able to simplify expressions that involve exponents, and we also want to use the order of operations to evaluate expressions. So maybe you've seen some of this stuff before. In that case, great. I hope it's a nice review for you, and let's make sure we're getting them right. So here we go. We got a nice little getting ready problem. So you've won a door prize. You get to choose between the two options shown, which is the better prize and why. So prize 1 tells me I get $60 immediately. Prize 2 allows me to get $1 for the first day, and then each day for the next 5 days, I get twice the previous day's amount. So I would get $1 on the first day. The next day I would get twice that, which would be $2. The day after that I would get $4, which is twice $2. So I'm going to leave it up to you to decide which is the better prize and why, and we will discuss this at the beginning of class next time. All right? So moving forward, one of our essential understandings is that we can use powers to shorten how we represent repeated multiplication, such as 2 times 2 times 2 times 2 times 2 times 2. Well, we can use an exponent to help us with that. So let's go. Here we go. Some vocab stuff. A power has two parts. It has a base and an exponent. The exponent tells you how many times you use the base as a factor. So how many times am I going to multiply the number by itself? You read the power 2 with a little 3 exponent as we would read that as 2 to the third power or 2 cubed. The 3, we read that as cubed. We read the power 5 with a 2 as an exponent, so a little 2 up top, as 5 to the second power, or most of the time you would hear that as 5 squared. Okay? If there were things like 5 with a little 4 up top, if this was a little 4 up top, we would just read that 5 to the fourth power. There's really no special name like cube or squared for things like that. All right? So looking back real quick, the 5 would be the base. The 2 would be the exponent. The 2 would be the base. The 3 in this case would be the exponent. So that's telling me to do 2 times 2 times 2. 3 2's. This is telling me to do 5 times 5. 2 5's. All right? We simplify a numerical expression when we replace it with its single numerical value. So a lot of times when you're doing a math problem, it's hard to understand the directions. So whenever they say simplify, that means figure it out so you get down to the most basic answer. So if there's only numbers in there, then you would just do what it tells you to do. For example, if it said simplify 2 times 8, well, then you would just get 16. All right. To simplify a power, you replace it with its simplest name. So, for example, if I was going to simplify 10 to the 7th, well, that means 10 times 10 times 10 times 10 times 10, 7 times. And if I simplify that, well, 10 times 10 times 10 times 10 times 10 on my calculator would give me 10 million. All right. If I look at number B, I have 0.2 to the 5th. Well, that means 0.2 times 0.2 times 0.2 times 0.2 times 0.2. And if I have my handy-dandy calculator, hopefully you do, ready to go, you'd find out that that is 0.00032. All right? 2/3 to the third. So 2/3 to the third means 2/3 times 2/3 times 2/3. Simplifying fractions, when I multiply is easy. Go across the top. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So 8 over 27. Okay, we got a little got it here on the bottom. Like we said before, the got it, give that a shot. So we'll let you try that. If you need to pause it, and go ahead and give those a shot. All right, essential understanding number 2 is when simplifying an expression, you need to perform operations in the correct order. So let's take a look here at an example. I have 2 plus 3 times 5. So if we wanted to simplify this expression, put it in its most basic form, there's 2 things you might try to do. First thing you might try to do is add 2 and 3 and get 5, and then multiply by 5 and get 25. Okay? Another thing you could do would be multiply the 3 and the 5 first, and then add the 2 to it and get 17. Well, we're getting 2 different answers here. So if they gave me this problem, Well, we need to have some way that we all get the same answer. So both of them seem sensible, but really only the second one, this 17, is considered correct. And that's because it uses an order of operations that, it's kind of conventional that mathematicians have agreed to use. So perhaps you've heard of it before. In your order of operations, I do anything with grouping symbol like parentheses or brackets first. A fraction bar is also considered a grouping symbol. So if I have a fraction, I'll do everything on the top first, everything on the bottom, and then I would simplify from there. The next thing I do after my parentheses or brackets is I do any powers or any exponents. So I simplify any expression with an exponent. Then from there, I'll be down to just having numbers and multiplications, divisions, additions, subtractions, and I do the multiplications and divisions first from left to right. I could do a division before a multiplication. So whatever comes up left to right, these kind of go together. And then I do my additions and subtractions from left to right also. So if a subtraction came up before an addition, I would do it, as long as it came up first from left to right. So I just read it like a book from left to right. As a memory device, this order of operations is often abbreviated with the acronym PEMDAS. All right, so perhaps you've heard that before. Or some people create a little expression. When I was in high school, they always taught me, please excuse my dear Aunt Sally. So parentheses, exponents, multiplication and division, addition and subtraction. All right, so let's look at a couple examples as we simplify. So in this example, the first thing I got to do is those parentheses. So 6 minus 2 is 4. All right. So I got 4 cubed divided by 2. Now I got to do my exponent next. So 4 cubed is 4 times 4 times 4, which is 64, excuse me. And then I have to divide by 2. Well, 64 divided by 2 is just 32. So I simplified it. I did my parentheses first, got an answer. Did my exponent next, and then I divided. All right. Here, remember, the fraction bar counts as a grouping symbol, so I got to do the whole top. If there was something to do on the bottom, I would do that. Then I would worry about the fraction. So there's no parentheses anywhere. I can do this exponent next. So 2 to the 4th, that means 2 times 2 times 2 times 2, which is 16 minus 1, and then divide by 5. So I have to do all the top first. 16 minus 1 is 15. 15 divided by, that's what the fraction means, 15 divided by 5 is just 3. All right, here we go in C. So no parentheses, we can just jump right to the exponent. So I see 4 squared, 4 times 4 is 16. All right, and now I got some multiplication, a little subtraction, a little division. So remember, go from left to right. Here's your first multiplication from left to right, 35. All right. Now be careful, you have to do this division before you do the subtraction. So the next thing I need is that 16 divided by 2, which is 8. 35 minus 8 is just 27. Okay? So there's a couple for you to try. So we got D, E, and F. All right, so go ahead and pause the video. Try D, E, and F. Remember your order of operations, your P, E, M, D, A, S. All right, your PEMDAS. Please excuse my dear Aunt Sally. And go ahead and work through those, and then we'll look at those in class. All right, when you're ready, unpause the video, and we'll go from there. So when 2 or more variables, or a number and variable, are written together, treat them as if they were in parentheses. So 4xy, this really means 4 times x times y, is equivalent to, well, 4xy. So I would do everything with 4xy first before I did anything with it. Xy squared. Well, I would just think of that as xy squared in its own grouping symbol. So if I had numbers for x and y, I would do all those first. I would have to do the y squared, then multiply by the x, all right, and then take that and use it. We evaluate an algebraic expression with replacing each variable with the given number. Then simplify the expression using the order of operations. So a couple examples. Evaluate the algebraic expression. What is the value if x is 5 and y is 2? So everywhere on the problem I see an x, I'm going to put a 5. And everywhere I see a y, I'm going to put a 2. So if I just substitute them into A, I'd wind up like that. 5 squared plus 5 minus 12, so the 12 didn't change, that's a constant. Y was 2, y is 2, so I just put the 2 in. All right, and anytime I put something in, I always protect it with his own little parenthesis. Notice the squared is outside of the parenthesis. This squared is outside of the parenthesis. The 5 is the only thing I'm putting in the parenthesis. That's what I'm plugging into the problem. Now I just follow my PEMDAS. So no parenthesis operations to do. There's nothing to simplify in these parentheses. So I can go right to exponents. 5 squared is 25. All right. 2 squared is 4, so I did that one also while I was at it. Now be careful, not addition, not subtraction. I got to do this division first. So 12 divided by 4 is 3. Now I can do addition and subtraction from left to right. 25 plus 5 is 30, minus 3 makes 27. Okay? Here, plugging in the 5, plugging in the 2. So I got 5 times 2. Again, anytime I plug it in, I always protect them with their own little parenthesis. This parenthesis that they gave me is still going to be there. And the squared is still on the outside. 5 times 2 in here. 5 times 2. The parenthesis they gave me is this one out here in the outermost. All right? So go from there. Simplify inside of your parentheses. That's your please part of your please excuse my dear Aunt Sally. 5 times 2 is 10. 5 times 2 is 10. Now I got to do this exponent first. 10 squared is 10 times 10 or 100 divided by 10. 100 divided by 10 is just 10. All right. Couple for you to try here on the bottom. So go ahead and pause it. Give those a shot. Hopefully we're doing all right. And then here's the last one for today. As we move forward, what is an expression for the spending money you have left after depositing 2/5 of your wages in savings? All right, so I earn a certain amount of money. I'm going to save 2/5 of that. My job is to write an expression for how much I have left, how much I can spend. All right, so your savings are 2/5 times however much you earn. I'm saving 2/5 of what I earn. So my savings are 2/5 of what I earn. So if I earn 40 bucks, if those are my wages, 40 bucks, well, 2/5 times 40 is 16 bucks. 2/5 times 50 is 20 bucks. All right? So whatever this wage is, I'm just multiplying it by 2/5. 2/5 times 75 is 30 bucks. 2/5 times 100 is 40 bucks. Okay? So this is how much I save. How much I can spend, well, that is how much I earned minus how much I save. So if I earned 40 and I'm saving 16, well, then I can spend 40 minus 16 or 24. If I earn 50 and I spend 20, well, then I can, save 20, well, then I can spend 30. If I earn 75 and save 30, well, then I can spend 45. If I earn 100, save 40, well, that means I can spend 60. All right, so look at what you did in the table. If W is the wages, all right, how much you earned, well, then my expression is just the wages minus the savings, right? The wages minus the savings. And the savings is 2/5 of the wages. So my spending money is the wages minus the savings. Well, the wages are W minus the savings are 2/5 of W. So my spending money is the wages minus 2/5 of the wages. Okay? Hopefully that table kind of makes sense to you. If you just look at the formula in the beginning, I think it could be a little confusing. But as you kind of walk through it, I think it makes pretty good sense. So that's it for now. Hopefully you have all those gots done, and make sure you have all the stuff filled in, and I look forward to seeing you tomorrow. All right? See you next time. Peace.